but what I want to do is to check and make sure that here that I actually did find the correct inverse function, that 1 minus 2y is the inverse. So let's see how to compose f inverse with f to make sure that we did indeed get the inverse function. So let me go to a new page here, and it's working green. So we have the function f of x equals 1 over 3x plus 2. And I'm not going to call it f inverse until I actually prove it now. Let's call it g of y equals what? 1 minus 2y over 3y? 1 minus 2y over 3y. Okay? And I'm going to compose these two functions, and hopefully it yields the identity function, which will show that I got the inverse. And we'll do it both ways. We'll do f composed with g and g composed with f. So first let's do f composed with g. F composed with g of x means we plug g of x into f. Well, f says whatever you put there, put it there. So to save room, let me say this equals 1 over 3 times g of x plus 2. Okay, this equals 1 over, now let's replace g of x. Oops, this should be g of y. G of y there. G of y. Forgive me. So 1 over 3 times g of y plus 2. So g of y is going to be 3 times 1 minus 2y over 3y plus 2. Okay? When I multiply here, you see that this 3 and that 3 are going to cancel each other. And so this is going to leave me with 1 over 1 minus 2y over y plus 2. Now, I need to get a common denominator so I can add this numerator down here. I want to add these two. And so what's my common denominator going to be? It's going to be y. So moving up here, we're going to get that this equals 1 over 1 minus 2y over y plus 2y over y. Note that 2y over y is this. I needed a y on the bottom, so to do that I need to multiply the bottom by y. But to keep it so I don't change y, I had to multiply the top and bottom by y. So I still leaves me with 2. That is, these y's cancel, and I still have 2. I haven't changed anything. But I don't want to cancel them right now because I want to be able to add these denominators. I mean, add the numerators. 1 over 1 minus 2y plus 2y over y. Okay? So now, moving up here, let's say, so that's going to be 1 over minus 2y and plus y, they cancel each other, so it's just 1 over y on the bottom. Alright? And we should know that if you divide by a fraction, that is the same as multiplying by the reciprocal. That is, this equals 1 times y over 1. Alright? And when you do this, you can think of these as any integer as a fraction. Just divide it by 1. When you multiply straight across. And so we get 1 times y is y divided by 1. So we just get y. Okay? So that is, therefore, f composed with g of y equals y. And we actually need we need to show it the other way. So that is, it yielded the identity function. That is, we plugged in y and it spit out a y. So g, there's a good hunch that it actually is the inverse function. We need to go the other way. Good practice. I think it might be good for you guys and gals to see it. So let's go the other way as well. So f of x equals 1 over 3x plus 2. G of x equals, or g of y. Keep doing that. It really doesn't matter, but let's go with it. 1 minus 2y. That is, it doesn't matter what you call the input, as long as that y, as long as this matches this over here, 1 minus 2y over 3y. So now I want to go the other way. So I want to do g composed with f, and this time because it's the f, so we're putting it as f of x. Okay, and this should end up just being x, the identity function. G, you input an x and it spits out x. So let's work it out and make sure. So this is g of f of x, which equals, g says whatever you put here, put it there, and put it there. So it's going to be 1 minus 2 f of x over 3 times f of x. Alright, now let's substitute in for f of x. 1 over 3x plus 2. So 3 times 1 over plus 2. Alright, so now let's go, we'll go right here. So that's going to be 1 minus, let's let the negative carry with the 2 and go and multiply times that 1. So 1 plus a negative 2 over 3x plus 2 divided by, so this 3 multiplies straight across, think it's 3 over 1. 1 goes to the bottom, so it's going to be 3 over 3x plus 2. Okay, and so now what do I want to do first? Let me go ahead and do this. I'm dividing by a fraction, so I'm going to change this problem here to this equals 1 plus a negative 2 over 3x plus 2, and instead of dividing by 3 over 3x plus 2, I'm going to multiply by 3x plus 2 over 3. Okay, so that distributes to both of these. So you distribute it here and then distribute it to the 1. So that's going to leave me with, when I multiply times 1, I just get 3x plus 2 over 3. And when I multiply here, note that the 3x plus 2 on the bottom is going to cancel the 3x plus 2 on top, so I'll get minus 2/3. Okay, so now let's let this 3 on the bottom here divides into both of those. When it divides into 3x, we're left with x. And when it divides into the 2, we're left with a positive 2/3. And then we have the negative 2/3 here, minus 2/3, which equals x. Okay, so we found that we got the identity function again. So therefore, g composed with f of x equal x, and before we got f composed with g of y equals y, and we showed it both ways there, thus we get that g of x is indeed equal to the or g of y does indeed equal to the f inverse, is our inverse function. Okay, hope that helped you guys and gals out.